All right, so there's interaction. So some of you identified that there are questions on magnets. Okay, there are questions on water. Okay, very good. Light. Okay, so some of you actually said that, okay, attraction and repulsion for the magnets, right? Did you identify this topic? Heat? Yes or no? Yeah, so these are the few topics. Yes, that's right. States of the water. Okay, very good. So it's good that you know. So roughly, you know this tutorial is about these topics. All right, so let's go on to the first question. A block of melting ice. Okay, this block of melting ice is placed in a beaker. As shown in the diagram below, what will happen to the temperature of the air in the beaker? So when they say temperature of the air in the beaker, so it should be in this area. Okay, so temperature of air inside the beaker, as well as the melting ice during the process of melting. So when the ice is melting, it is taking heat from the surrounding air. Okay, so this ice will be taking in heat from surrounding air. Okay, so heat, if I were to erase away all these curly lines, okay, so the heat will be moving in if I use these arrows to represent how heat is moving from a warmer place to a cooler place, right? Yes or no? So where is the warmer place? The warmer place will be the surrounding air, right? So you must remember the concept. Okay, concept of how heat flows. Heat is always flowing from a hotter place or a warmer place to a cooler or colder place. So this big block of ice, yes, very, 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 very cold. That's right, Remus. Okay, this is a very big block of ice, very cold. So heat will be moving from a warmer place to cooler place. That's why when the ice took in the heat from the surrounding, it starts to melt. Okay, so what will happen to the temperature of the air in the beaker? Loses heat to the ice, right? So it's going to decrease in temperature. So we know that it's going to decrease in temperature. So we have these two options, right? Okay, we can already cross out by elimination, A and B. Left with C and D, you need to decide now. Temperature of melting ice, will it remain the same or is it going to become colder? This is not possible, isn't it? All right? This is not possible. During melting, temperature stays the same. Do you still recall this part from school? During melting, the temperature of water or the ice remain the same. Okay, until all the ice has melted. Must remember this part. Okay, so answer is C. Any question here? Let me see here. Most of you got this correct. Yeah. Okay, so if you have gotten it the other way around, okay, then think about it, okay? Temperature of the melting ice. The ice is still melting. Must remember, during melting, temperature of the ice remains the same. This is commonly tested. Right, so let's go on to the next question. Okay, Alice wanted to find out how the exposed surface area of a handkerchief affects the time taken for it to dry. She hung 3 identical handkerchiefs, A and B and C, containing same amount of water. I highlighted the important words here. Same amount of water out in the sun. Each handkerchief was folded to expose a different amount of surface area. Okay, so the 3 handkerchiefs will wait after half an hour. All right, so the results are shown in the graph below. Now, let me just talk to you about how this surface area thing happened. Can you all visualize how this happened? Okay, whether it is being folded in certain way to have the exposed surface area. Do you have any problem here with visualizing? Okay, so imagine one piece of handkerchief being folded. Okay, so when you fold it once, okay, so the exposed surface area is going to be half, right? So if I say it and you can't see it, I'm going to use this to show you. All right, so this is the piece of handkerchief. The first piece, for example, okay, where it's open up. Okay, this handkerchief is opened up. The second piece of handkerchief, similar one, because we know that from the question, it's 3 identical handkerchiefs, A, B, and C. All right, so second piece, it's folded. So now you see the exposed surface area is actually reduced, right? By half. Okay, this is not very straight. Okay, so it's actually reduced by half. The original one, exposed surface area, is huge, one whole piece of this handkerchief. So it's halved in this handkerchief. And if there's another piece of handkerchief, the third one being folded in this manner, all right, when it's completed, when the folding is completed, maybe I draw by the side, it's going to be this surface area only. Can you all see this? Okay, so which handkerchief, when they are soaked with the same amount of water, Shen, when they have the same amount of water, right, which one will dry the fastest? Okay, if I were to say, okay, if I were to say this is handkerchief 1, handkerchief 2, and handkerchief 3, which one? Handkerchief 1, right? It will dry the fastest. So what does it mean by dry the fastest? The water will be lost fastest, right? Yes or no? So that means this, because it has the greatest exposed surface area. All right, so water fastest. All right, so if I were to ask you, then which line of this graph will show that? All right, which line of this graph will show that? Now, then you will start asking me, so what does the starting point means? So what does the starting point means? Do you see that I have already highlighted for you? All right, when you talk about the same amount of water, then another pointer given here is being weighed. So when we talk about being weighed, we are talking about mass. You know there's water, then these handkerchiefs are being weighed. So we are talking about the mass of water that they are measuring over here. Okay, then what is this x-axis then? What do you think is this x-axis then? This must be the time. Okay, this must be the time. Yeah, Zikin, thank you so much for typing in. Right, so this is where you have 30 minutes later. Correct, so we started off at 0 minute. Okay, half an hour later, weigh the handkerchief again. Right, so the mass of each handkerchief will be shown here. So you can see that C has the lowest mass. Agree? Lowest mass also tells us that least amount of water. Are you all following? Yeah, very good. Aditya, you also put in the answer there. Very good. So least amount of water. So which is my handkerchief C? Is it 1? Is it 2? Is it 3? It has got to be 1, isn't it? Yeah. Okay. Yeah. Right. So this must be my handkerchief C. Why is this handkerchief C? Because it has the lowest mass of water after 30 minutes. That means water already evaporated. A lot of this water already evaporated. Clear? Okay, I'm explaining to you this in detail because we had students who cannot understand this part. So just in case some of you are not telling me you don't understand, I'm going to explain in detail. So greatest exposed surface area, water is evaporated the fastest. So at any point in time, it will have lesser water, okay, lesser water compared to the other two handkerchiefs. Clear? So in this case here, okay, if I have my number 2, what do you think is the line representing it? Or which handkerchief represents it? Must be B, right? Okay, because it has it's just right in the middle. The amount of water that is in the handkerchief is just in the middle. All right. So the one with the smallest exposed surface area meaning least or shall I put it the same way? Okay, if water is evaporated slowest. Okay, water is evaporated slowest. It takes a longer time for the water to be totally evaporated. So this must be my number 3, right? Highest mass of water remaining. So this has got the highest amount of water in the handkerchief. Any question here? Okay, so if you don't understand, you have to refer to this slide. Okay, look at how the handkerchiefs are being hung, okay, to dry under the sun. So if I go back to the previous slide, okay, our answer is actually B. Okay, I went on to explain to you how the handkerchiefs look like. Okay, because some students were asking me, how do you know what is the meaning over here about the exposed surface area? Okay, if you recall when you are drying or you're hanging out the clothes for your daddy or mommy, okay, when you're hanging the clothes, you are supposed to spread out as much as possible, isn't it? Okay, do you fold your clothes and then try to dry it after that? Do you fold it nicely first, since after drying you have to fold it, right, and keep it in the cupboard? Correct. Do you fold first and then hopefully it dry fast? It's going to take a long time, right? I know Irene is going to laugh already. Okay, nobody will do that. It will take a long time. You always spread out. So when you spread out, it will look like this. Greatest exposed surface area. Okay? Next question. Now, Ali touched the glass of cold water as shown. His hand felt cold. Okay, so you're supposed to explain why his hand felt cold. Now, for this question, it has got to do with heat. Okay, and then we know that heat flows from a warmer place to a cooler place, right? Okay, so where is the warm place? It's Ali's hand, right? So Ali's hand is warmer. This cold water, we would think that maybe it's around 6 degrees, 7 degrees, 8 degrees, depending on how cold your fridge is, okay, or how much ice you have put in before it all melted, okay? So heat will flow from Ali's hand to the cold water. So general statement is, or the concept we are looking at is heat flows from warmer place to cooler place. Okay, in this particular example, in this question, the context is we are looking at Ali's hand as well as the cold water. So heat will flow from Ali's hand to the cold water. So Ali has lost some heat. Correct now? He has lost heat from where to where? From his hand to the cool water. So which statement tells you the correct option here? Okay. Answer is A. Let me see whether all of you got this right. Some of you didn't. You have to write down the explanation. Xiang Kun, you made the error here. Do you understand why you're wrong now? You know, okay, it's the way they phrase it. Okay, the way they phrase the statement, it sounds similar, but actually it's wrong. Okay, so you have to be very careful. In this kind of question, they are not just testing you on concept, they're also playing with words over here. Yeah, so there is heat loss from his hand, okay, to the glass.